This is a lesson, trig functions of any angle. It's lesson 3 from unit 10, and I'm going to look at number 6. The directions say the given point is on the terminal side of an angle in standard position. Determine the exact values of the 6 trig functions of the angle. So this is the exact ordered pair that I'm provided. And so I'm going to graph that. I go to the right a distance of 3 radical 2 because it's positive, and I drop down a distance of radical 6. Now, why did I not put a negative sign here? That's often a point of confusion because distance is always positive. The negative simply tells me to go down. Let's figure out what is this length. I'm going to use the Pythagorean theorem. The two legs can either be the a or the b. So a squared plus b squared equals c squared. So I'm going to expand this. 3 radical 2 times 3 radical 2 plus radical 6 times radical 6. 3 times 3 is 9. Radical 2 times radical 2 is just simply 2, and radical 6 times radical 6 is simply 6. 18 plus 6 is 24. Now I'm going to take the square root, and I'm going to simplify it. So I'm choosing a perfect square, which is 4 times 6, that equals 24. And normally we would say plus or minus, but because we're talking about distance, it's only going to be positive. Remember, our 6 trig functions are just a ratio. It's looking at a right triangle and choosing two sides and comparing them. So I'm going to use Oscar had a heap of apples as a way to remember how to choose the two sides. Then I'll go back later on and choose, are these 6 trig functions positive or negative, using the acronym all-star trig class. Let's get started with sine. Sine is opposite of this angle over hypotenuse. Opposite over hypotenuse. So opposite over hypotenuse. I'm going to come back to this in a little bit. Okay, then cosine is adjacent over hypotenuse. Adjacent over hypotenuse. 3 radical 2 over 2 radical 6. Tangent is going to be opposite over adjacent. Opposite over adjacent. Radical 6 over 3 radical 2. All right, so when we look at this, I'm able to see that square root of 6 and square root of 6, we think they just cancel or disappear. In reality, they're going to simplify to 1. So this simplifies to 1 over 1 times 2 is 2. And then now I can easily come down to the cosine, to the cosecant, which is the reciprocal of sine, and I'm going to take the reciprocal of it, which is just 2 over 1, or I'm going to flip that fraction. Again, at the very end, I'm going to determine the signs. All right, let's go to cosine. So what can I simplify here? Well, these two just can't be canceled out, but what I'm going to do is I'm going to rationalize the denominator. So now I have 3 square root of 12 over, well, 2, and this would be the square root of 36, which is just 6. Okay, I'm going to have to do a little more work here. I'm going to come off to the side here. So I have 3 square roots of 12 over 12. Well, this reduces to 1 over 4, but I'm not done yet. Square root of 12 over 4. Now, all of that is fine, but it's still not fully reduced because there's a perfect square, specifically 4, that can break 12 into 4 times 3. Square root of 4 is 2, so I have 2 radical 3 over 4, and it finally simplifies to 1 times the square root of 3 over 2, or simply the square root of 3 over 2. Let's flip this around to have 2 over the square root of 3, because cosine and secant are reciprocals of one another. Now, although this is correct mathematically, it's not proper, so I'm going to take this times the square root of 3 on the top and the bottom to get 2 radical 3 over, well, 3 times 3 is 9, and square root of 9 is 3. All right, the next one here, similar to what we did with cosine, I'm going to have to extend this and go times 2 and times 2. Now I have the square root of 12 over, well, 3 times, well, 2 times 2 is 4, and the square root of 4 is 2. Let's come off to the side here again. So I have the square root of 12 over 6, and just like I did up here, 12 breaks into 4 times 3 over 6. So 2 radical 3 over 6, and reduces to 1 over 3. So 1 times the square root of 3, and again, the 2 and the 6 reduce to 1 over 3. Now when I flip that, I get 3 over the square root of 3 because tangent and cotangent are reciprocals of one another. I'm going to multiply both the top and the bottom by the square root of 3 to rationalize the denominator. And I have 3 radical 3. 3 times 3 is 9. The square root of 9 is simply 3. And we can see that my 3's are going to simplify. Okay, now let's go back and let's determine the signs here. We want to use that acronym all-star trig class. All-star trig class. That will be important. Okay, So this is in quadrant 4. In quadrant 4, only the cosines are positive. So cosine, this is a positive, and its reciprocal are positive. Everything else has one negative. Now where that negative is placed is up to you. It can be the top, the bottom, or in the middle.